Good afternoon. Our today's session is on what are the main components of RAG system. Now, this is going to be a short session where we are going to cover how does RAG works, RAG versus fine tuning, and also how to implement RAG for AWS and cloud, Google Cloud. Okay, so in our previous session, we had discussed what is RAG, that is Retrieval Augmented Generation. What are the benefits? Just a small recap that it is used to enhance the LLM models. Okay, for example, ChatGPT if you are using. So how does it work? So internally, it has a RAG model. So RAG in terms of tree, if it's a closed tree, then it's a graph, that data structure. So it uses the external resources. And we have got lexicon tree, lexicon. And a lexicon table is there where suppose if we are considering a sentence, text sentence, so words are segregated, then semantics is attached, syntax is attached, okay? Then we find the external resources associated to those words. And there is a flow process where we attach we create a RAG tree where we attach a key that is called an index. So we can embed the external data on every node of the tree, right? Then we convert the user's prompt in the LLM into a vector using RAG, okay, so that we can retrieve the top matches. For that, Oracle is doing a great job. And then we augment that prompt to get the output. So again, documents are retrieved from the nodes, child nodes of the tree using Greeks of Greeks. Correct. We had also discussed about the importance of RAG. So the user submits the query. Okay. Then the query is converted into a vector that is called semantic embedding. So semantics is attached in the lexicon. Then the tree is parsed. Okay. A grammar is attached. Rules are attached. And the retriever finds the relevant documents from the vector databases. So this is all related to a user, but internally we have got a lexicon, we have got a semantic analyzer, we have got a syntactical analyzer, context-free grammar is attached using grammar rules, parse trees. And for the context, the RAG finally is developed so that you get an unambiguous outcome. Okay. So a system builds an augmented prompt. So from the child node, finally you get the documents that called the augmentation. So the LLM generates the answer. So who is helping it? Through the RAG. So RAG has all these features, the syntactic tree, the lexicon. So I'm repeating this again and again so that you finally understand that how the LLM generates the answer. And there is a RAG is fine-tuned. Okay, so that we are going to discuss that how fine-tuner and RAG is compared so that we get a better quality and context and unambiguous outcome. So we have a query processing. So in DBMS, if you have learned as a CSC subject, we have got augmented rules. Fine. So we have got 6 axiom rules. For that, first we find out the functional dependencies. So functional dependency is A implies B. That means B is dependent on A. For example, we have got a roll number and we have got a name of a student, right? So student is dependent on roll number. That means if roll number is same, fine, the student name should always be same. It's not necessary that it should be vice versa. Why? Because same roll number can have different roll numbers can have same name. Maybe that's a coincidence that the first name and the last name is also the same, right? So A implies B, but it's not necessary that B should implies A. But we've got 6 augment rules where you can say that if one of the rule can say that if A implies B and B implies C, that means the 6 axiom rule follows that A implies C, correct? So these axiom rules, for that we need to understand from the query which has been given from the prompt from the users. Okay, so users query input is encoded in a vector embedded. So one of this functional dependencies and axiom rules is a part of the vector embedding where we try to go to the relational databases. So internally, even a vector is converted into a relational table, And from there, we can fine tune the words through query processing. So if you have learned DBMS, you know how to use query processing in the form of select. Okay, so with different permutation and combinations, you can actually find out the best matching. So that will help you. So what extensively RAG is using is the vector embedding, and of course the relational concepts, database concept, where you have the query processing. So the query next phase is the retrieval, where the query vector searches the databases, okay, to fetch the top K. So for that, you need to, segregate the data into similar chunks, and you can use the concept of cosine similarity and other metrics features, okay, to, similar chunks into query vectors. So here, this is nothing but the chunks. So the user query comes, the relevant data, correct? So finally, it goes to the embedding models, that's a vector spaces, and through RAG, and it goes to the vector databases then. So model trained into databases. So you can have a MVC model if you are using Java. So model, MVC stands for, M stands for model, V stands for view, and C stands for controller. So whatever model, if you have learned software engineering and architectural patterns, okay, so we have got architectural different patterns. MVC is one of the architectural pattern, and then we have got a lot of design patterns for your factory generation. Okay, so that concepts need to be clear to understand these embedding. I'm just telling you an overview of how the RAG works. So it will be converted into vector databases. So this is, if you want to create an LLM, you have to go like this. But when you are retrieving the data, it will be retrieving data from the LLM through linking the sources of the data and the embedding. Then it will finally find out the chunks which are relative, and then appending related to the chunk to the query, and it will get you the relevant data. Correct? So this is how it works, and the data and the query is retrieved from the internal RAG model, where you have embedded model and the vector databases. Then the relationships through context that we understood in our previous session. I'll share you the playlist so you can go through that. But if you want to create an LLM, then you have to create all these things which are described over here. Okay, finally. So again, I'll repeat, the second phase is the retrieval, where the vector databases searches the database from the top K similar chunks. And what is the internal? The cosine similarity or the other similarity metrics you can use, whatever the LLM you have created on. Then third step is the augmentation, where the retrieved chunks are combined with the original query to form an enriched prompt, providing factual context to the LLM. So the site which makes this software is the merge. Okay, there is one more site which you can go and see, that is blog how tag works. So finally, this is again an LLM. This is again an LLM, Greeks agree. So this LLM is an embedded LLM used for the RAG model for the augmentation. Okay, so you need, this is called agentic AI. So everything a single LLM may not know. You can use LinkedIn for query processing. It's a very good tool. So that's an agentic AI. So for query processing, LinkedIn can be used. Of course, there's one more plus one means there's one more source which you can use. This is my suggestions. Okay, but I'm also telling you what frequently the LLMs are using. So these all steps can be a different agentic AI. So for augmentation, you can use agentic AI merge, but what finally merge will do? It will retrieve the chunks combined with the original query and form the enriched form. Okay. So it will combine the chunk and your relevant query, and it will finally give you the relevant data. So how this procedure will be done on the merge. Fine. This is what is explained here. Then generation, next phase, the augmented prompt is fed to the LLM, which generates a coherent response grounded in the retrieved data. So coherent response means the exact relevant context. Okay, it will attach the context on this phase. And then finally, after the augmentation, now augmentation will go to the node of the tree, as explained in the previous session, and it will retrieve the documents. Okay, and those it will merge also. That is augmentation. But finally, out of that merge, it has to generate a text which will the user will be shared. So that task is done by agentic AI data cam. Fine. So you can do this generation using this over here. And the last phase is the objectional ranking or the refinement. So results may be scored and filtered for relevance before augmentation. So LinkedIn is one of the agents that can, if suppose there are 5 augmented data, correct? It will generate into 3 coherent response. But finally, it will give data only 1 to the user. So what happens? Sometimes you get a response and then you get a message from the chat GPT. Do you want this as a PDF version? Do you want as a PPT? Or do you want to go ahead with the another model? So these 3 other models are the subsections of the generation phase. Okay, the augmentation phase. And the generation phase will give you the top 1, okay, which will be ranked by the LLM. But the generation phase has 3 phases. That means it has already created the PDF, it has already created the PPT, but it will not give you all the 3. It will give you only 1, which is top ranked by the LinkedIn. And it will give you the suggestions, which it has already generated. Okay. So PPT is a different vector space. PDF is a different vector space. But during the generation, it has not created, but it has taken the retrieval from the augmentation. It can also be there to save the space. That can also be done. So the example of this workflow is that for a query like latest on quantum computing, if this is the query given on the prompt, right? So how does the RAG work? It will retrieve recent papers. It will augment the prompt based on these documents. That means whatever recent papers, okay, it will create chunks on the base of cosine similarity, okay, because these recent papers will also have different keywords attached to each paper. If you just recollect, in our research paper series, I have told you the importance of keywords. So whenever a Google engine searches any prompt, it will, on the Google, it will take the title of the paper which are stored and the keywords which are attached. This is how the indexing is done in the RAG, okay? So suppose the RAG has quantum computing plus other keywords, okay? So those keywords can be segregated and create chunks. Fine. So quantum computing, say you have 10 papers on quantum computing and big data. You have got 10 papers on quantum computing and deep learning. So 2 chunks will be created, for example, one on quantum computing because your main question is on quantum computing, but you will have 2 vector spaces, one on big data and one of deep learning, likewise. And then it will generate the factual summary. So it can give you summary. That means it will be augmented on 2 things because there are 2 vector spaces in this example. And then the generation will be either it will give you a summary of both the deep learning and big data, or it will give you one and it will ask you, as per in LinkedIn, it will be said that no, quantum computing is majorly used in deep learning, for example. So it will give you the outcome as deep learning because LinkedIn has said that. But generation wise, it has given you a vector space of big data also. So it will give you in the suggestion. Do you want even for the big data? Likewise. Correct? So depending upon the factual summary. What is the factual summary? That the LinkedIn has said that mostly work has been done on deep learning. But so the summary will come out based on deep learning. But it will not ignore the vector space of big data as well. So this is how the workflow will work. So this process repeats per query, keeping response fresh without retaining. So as per the refinement from the user's prompt engineering, okay, this RAG tree will become more and more deeper. And what helps it? Now see, whenever you log in, you get your previous data and the processing starts from the previous data. So where it is stored, you need a particular space, right? Where all your RAGs, queries, prompts is there in your chat GPT, for example. So it is storing in the AWS, sponsored by Amazon. So these are tie-ups. So if you think that ChatGPT is working alone, no, it has got a cloud inside. So that is why in our next session, okay, we are going to discuss how to integrate RAG in AWS and the importance we have just understood by this workflow. Okay, so in this session, we have actually covered in detail how does the RAG work step by step. But one of the sub main topic of this particular session was that what are the main components of RAG system, correct? So the RAG system, the core components are the knowledge sources, which we have discussed in our previous session. Just now also we discussed the embedded model, the vector database, the retriever. So who is going to retrieve? The Oracle, because we just saw that for the query retrievals, Oracle is the best. Also, there is one more thing, retrieval, Greeks of Greeks. So in the previous session, we discussed about the Oracle and Greeks for Greeks. So these two will do the query processing vector searching based on cosine similarity. And this phase is achieved here. Okay, retrieval. Then next is the prompt argumenter. So for retriever, Greeks of Greeks, Oracle, and the one more semantic search engine which is involved is Amen. Okay, so what Amen does, it tags end-to-end different components, and gives you as a query optimizer. तो आप जब कोई query लिखते हो, select star from table where attribute 1 and attribute 2. So these attributes will come from the Amen's tags that helps you to fetch the top k relevant chunks based on the cosine factor. Okay, so and then you have got a generator LLM. Okay, finally, this also hallucinations, for reducing hallucinations. This particular agentic AI tool, okay, or website is being used by majorly LLMs. I'm just giving you a suggestion or recommender, but you can incorporate your own, or maybe some things are highlighted, some things are not highlighted. They are confidential. Okay. So just to giving you a gist, these are the interactions. So again, I'll repeat, what are the main components? Knowledge source, embedded model, vector database. Okay, so it stores the embeddings with indexing. Fine. So what type of it's using? If you have learned machine learning, it uses the nearest neighbor searches. K neighbor. Okay, K means for clustering. If you remember, K means algorithm. If you have learned, or you can go back, it's a very commonly used clustering algorithm for machine learning. So those clusterings can be used for creating similar clusters. So that is called as vector databases. Okay, you can go through this diagram, that chunking splitter, embedding converter, vector databases, similarity, search, and then grounded answer. So this is another pipeline RAG model and the phases. So on this query processor, fine, you can use the k nearest approach. Fine. And that k nearest approach on similarity search, it will again go to the embeddings converter. Because if the k nearest neighbor says that we need 7 vector spaces, correct? And initially embedded converters had created only 3. So it will go back and now refine it into 7. Maybe it has created 7 initially, but out of your query and mostly people search engines, it has come to find out that 7 is creating complexity. Let's land up into 3. That training will be done by K neighbors, or K means clustering algorithm. So we need to go back, fine, and we need to understand. So this diagram and this diagram, you can again, I request you to draw these diagrams in your notes. So by understanding this video, okay, you can just recollect the phases again. So coming back to the core components, it's the prompt augmenter and it's the generator. Okay, so these are the different components. So how do they interact? So data flows sequentially, pre-processes and index knowledge. Then there is an embed query. Then it retrieves, then it augments, and then it generates. This is the data flow of our RAG model. How does it works sequentially to, these are the components, but there has to be a certain flow, right? So the flow which I've mentioned here, this is, if you just incorporate this sequentially, it turns out to be your RAG workflow, which we have discussed previously. So in our next session, we will be covering what are the challenges of RAG, okay, and RAG versus fine tuning, which is better, and of course, finally landing up of how to implement RAG using AWS Cloud. So this session was mostly compiling in detail about the different components of the RAG model and how does the workflow operates, what are the different phases in detail. So thank you very much for your patience listening. Okay, I'll share the playlist of the previous lecture and the coming lecture of these series in the description box. You can go through that. Also, I'll share the link of this notes through SlideShare so that you can download it and refer. So thank you once again. Have a nice